So now we are going to more carefully look at this equation that we derived here. And the top experiment, the top figure is that where I keep T constant, I say in composites, we managed to fill gaps between fibers that when T was about 700 nanometers. Now, you might say it's not exactly 700 nanometers, and I wouldn't disagree with you. I just say it's not 7 nanometers or 70 nanometers or 7 microns. You know, within an order plus or minus 10, 20, 30%, we got it right on average. So what you see is that then if the diameter goes up, volume fraction can also go up while maintaining T. Okay, so, and this is not surprising at all, but what is important to note is that this point, 68% of 5 microns, that's where we calibrated our model. That's how we got the 700 nanometers. That was 5 microns, that is microfibers, 60 volume percent. But what makes it interesting is that now if I go way down, and I say the diameter is half a micron, then I wouldn't be able to go way above 5, 6, 7% unless I will get a lot of problems with filling the gap between them. Or if I go even further down, I will have even more problem. And that's why on average, you see that if I keep T at 700 nanometers and I reduce I reduce diameter to about 100 to 200 nanometers, the volume fraction I will get is in the order of a few percent, and filling above that is going to be really challenging. The same graph is plotted here. This is now more an wish list. If I wanted to keep volume fraction at 60%, what would happen to T when diameter goes down? When diameter goes down, a volume fraction is fixed, T has to go down. How down? How low does it get? In the case of microfibers, that's about, in the case of microfibers, it's calibrated at 750 nanometers. But when I go to nanofibers, this gets much, much smaller, and T becomes so small that it's really not manageable. So, and because of those things, typically when we talk about nanocomposites, the volume fractions we're dealing with are really small, 1, 2, 3%. And yet they can have a significant effect on many properties, but that ability to fill the gap between them with resin really limits us. And a lot of times we'll end up with agglomerations in nanocomposites because they can come together and the bending and stiffness is not a match to keep them away from each other. So I'm going to stop here and continue on this slide in the next video.